This videotape will show you some of the common types of shoulders and corners that are machined on the lathe. You will also see the tools and methods used for these machining operations. After viewing this videotape, you should be able to write down the safety procedures for machining shoulders and corners. Describe the common types of machined shoulders and corners and how they are used in the manufacture of parts. And describe the tools and procedures to use for machining common shoulders and corners. To perform these machining operations safely, remember to wear safety glasses at all times. Remove rings, watches, and jewelry. Keep your sleeves rolled above the elbow. Use reduced spindle speed RPM for forming tools, and keep the work overhang as short as possible. A shoulder is the step or surface which joins two different diameters. The three most common shoulders are the square shoulder, the filleted shoulder or corner, and the angular shoulder. The square shoulder can be machined into parts that are to be fitted together, particularly on work that is not subject to excessive strain at the corners. This shape provides a flat clamping surface and allows parts to be fitted squarely together. Filleted shoulders or corners are used on parts that require additional strength at the shoulder. These shoulders are turned with a round nose turning tool or with a forming tool ground to the required radius. Angular shoulders are not as common as filleted shoulders, but they are sometimes used to strengthen a corner. They also eliminate sharp corners and improve the appearance of a part. Angular shoulders are not as strong as filleted shoulders, but they can be produced more economically. To machine an angular shoulder, you can use a side finishing tool or a turning tool set at the proper angle. External corners may be machined to break the sharp edges and add to the general appearance of the job. Some common types of machined corners are the square, the rounded, and the chamfered corner. To machine a square shoulder, place the workpiece in a lathe chuck, with the work extended approximately 3/8 to 1/2 inch beyond the length of the shoulder. Select the correct spindle RPM and check the power feed for the proper direction of travel. Using calipers, lay off the length of the shoulder. Mount the tool in the tool holder so that it extends just far enough for the machining operation. This precaution can prevent tool breakage. You can use the micrometer stop to determine the shoulder length by setting it up on the way of the lathe. Use the cross feed to pick up the cut on the end of the work. Take a depth of cut for roughing that is suited to the type of tool you are using. Now make the roughing cut to approximately 1/64 inch away from the line marking the length of the shoulder. Set the micrometer stop so that it stops the travel of the carriage at this point. The micrometer stop will ensure that successive cuts stop at this same point, thus determining the rough shoulder length. Continue taking successive cuts until the small diameter is within 10 to 20 thousandths of the specified diameter. Remember, you have also left about 1/64 inch on the length to use in finishing the part. Remove the roughing tool and set up the side finishing tool. Loosen the micrometer stop and touch the tool to the rough machined shoulder. Set the micrometer stop to the finishing length. Using the cross feed and carriage, rough machine the small fillet that has been left in the corner of the shoulder by the round nose of the roughing tool. Now move the tool to the end of the small diameter and touch it to the end of the work. Set the cross-feed dial to 0. Move the tool past the end of the work and set the cross-feed in to take a light finishing cut. Engage the carriage feed and machine approximately 1/4 inch on the end of the small diameter. Disengage the clutch. Move the tool to the end of the workpiece and check the diameter. Move the crossfeed in the required amount to machine the desired finish diameter and set the crossfeed dial to 0. Engage the clutch and make the finish cut. This should be done in one pass. When the tool has almost reached the micrometer stop, disengage the automatic feed and move the carriage to the stop by hand. Then use the cross feed by hand to feed the tool outward from the diameter. This cuts the shoulder to length with a smooth machined finish. Shut the machine off and check the shoulder for length. If the length is not to specifications, move the tool back into the diameter or the 0 setting. Change the micrometer stop the desired amount and machine the shoulder to length. Shut the machine off and check the diameter and length, and the part is finished. To machine shoulders to close tolerance lengths with this method, use a depth micrometer to check the length and determine the settings of the micrometer stop. To machine a filleted corner to a given radius, place the work in the chuck, extending approximately 3/8 to 1/2 inch beyond the length of the shoulder. Set the spindle RPM and check the direction of the feed. Set up the roughing tool and lay off the length of the shoulder. Now rough machine the diameter, leaving steps to provide material for machining the filleted corner. To do this, stop a little short on each roughing cut. After the diameter has been machined to within 10 or 20 thousandths of the specified diameter, remove the roughing tool and set up the radius tool in the tool holder. Touch the tool to the shoulder and set the micrometer stop. Use the carriage and cross feed to rough machine the square shoulders from the fillet and give a rough filleted corner. Remember, when you use a radius tool with a large radius for forming, you may have to reduce the spindle RPM to prevent chatter. Pick up a cut on the end of the work. Then move the tool off the end of the work and advance the cross feed to take a light cut. Machine approximately 1/4 inch on the end of the diameter. Shut off the machine and check the diameter. Move the tool past the end of the work and set the cross feed to give the specified diameter. Start the machine and use the power feed to machine the diameter to finished size. Turn off the power feed before the carriage touches the micrometer stop and move the carriage to the stop by hand. Hold the carriage against the stop with your hand and use the cross feed to feed the tool out from the diameter. Shut off the machine and check the diameter and length of the shoulder. If the length is not to specifications, bring the tool back to the diameter and reset the micrometer stop. With a forming tool of this type, you can also machine in toward the center of the work to bring the shoulder to length. If you do, be careful not to go past the diameter and gouge the fillet. Be sure in machining filleted shoulders that the gibs on the crossfeed are tight enough to prevent the crossfeed from being pulled into the work. The setup for machining an angular shoulder is slightly different from those for machining square or filleted shoulders. You can still use the micrometer stop to determine shoulder length, but the compound must be set to the angle to be machined on the shoulder. For this demonstration, the angle is 15 degrees. Set the compound toward the headstock to cut the angle. Select the correct RPM and check the feed direction. Set up a roughing tool in the tool holder and place the work in the chuck. You may have to allow more overhang for this operation to give clearance between the chuck jaws and the compound. Lay off the length of the shoulder. Before you start this operation, touch the tool to the shoulder and turn the chuck by hand to check for clearance. Set the micrometer stop at a depth to rough the shoulder. Rough the small diameter, again stopping short each time to leave material for cutting the angular shoulder. Change to a finishing tool and set the crossfeed to the finished diameter. Then set the compound dial at 0 and the crossfeed dial at 0. Machine approximately 1/4 inch on the end of the diameter. Shut off the machine and check the diameter. Reset the crossfeed if needed and 0 the crossfeed dial. Using the power feed, machine the small diameter to finished size. When you reach the rough shoulder, shut off the power feed and use the compound to feed the tool away from the diameter at a 15-degree angle. The carriage should be against the micrometer stop for this procedure. Move the compound back into 0. Move the micrometer stop to give the correct shoulder length. Move the carriage by hand until it hits the stop. Then use the compound again to move the tool away from the diameter. Now you have completed the parts with the desired diameter and angular shoulder. Square corners are machined into workpieces in normal operations, such as facing and shouldering. They are not usually desirable because of their sharpness. The sharp corner should be removed with a file or cutting tool, unless the drawing calls specifically for a square corner. Chamfered or angular corners may be turned with a compound or with the side of a turning tool. This is usually done to break a sharp edge. To chamfer the corner, set the compound to the desired angle. Use the compound feed to move the tool back and forth across the corner until the chamfer is the desired width. If the angle is not critical, you can turn a tool bit in the tool post and feed it against the corner. To machine a rounded corner, use a forming bit ground to the desired radius. Set the tool at center height and use the cross-feeding carriage to bring the tool into contact with the corner. Take small cuts with a carriage and feed the cross feet simultaneously back and forth. Using a tool bit on rounded corners of 1/32 of an inch or more is usually much faster than filing. You have been shown 3 common types of shoulders: the square shoulder, the filleted shoulder, and the angular shoulder. You have also seen the tools and methods to use in machining these shoulders. You have been shown 3 types of corners and how to machine them. And you have been shown some of the safety precautions to observe in performing these operations. Shoulders and corners are generally not machining operations by themselves, but are steps in machining parts to shape, size, and finish.